Hey everybody, welcome to another video. This one's not a constant support video. I just wanted to make a general video kind of showing you guys how you can play with graphs on Desmos to try to get used to what functions look like and help you understand how functions would look when they're graphs. So first thing I wanted to kind of show you is a proportional equation, right? So you guys know that whenever you're working in Desmos, if you want to insert a function or an equation, you're going to put the plus sign and then push f of x, and that will be able to generate an equation. I'll give you a space to generate an equation, okay? And then you just type in y equals kx, and that would be a universal equation for a proportional line. So they ask you, if you put y equals kx, do you want to add a slider for k? It basically means, do you want to be able to change the value of k and kind of see how it affects things? And so yeah, you could do that. You could add a slider for k. So this red line here that you're looking at is a proportional line. Now a proportional line is a line that starts at 0, 0, always, and then continues from there at a constant rate. So the ratio of y over x is the same throughout the entire relationship. That's what a proportional line looks like. Now if you have a value of 1, that means as x increases by 1, the y also increases by 1. So you can see, like right there, you'd have the value 1, 1, right? As x increases by 1, y increases by 1. Notice that a proportional line like this one that has a positive multiplier, right, k of 1, is going to be going up from left to right in a consistent way. So it's a line that goes up in a predictable way, and it always starts at the origin. If you were to adjust that value of k, okay, the multiplier, it's basically changing the slope of this proportional line. So if you increase the slope, okay, it's going to make it a steeper line. You can see how quickly it gets steep. If you decrease the multiplier, the slope, then it's going to get a more gradual line, right? Less steep. As long as that slope is positive, even if it's super tiny, right? Like k is 0.1 right now. You can even make k 0.01 or 0.001. And it's going to look closer and closer to a flat line, right? But as long as that is a positive value that's greater than 0, you're going to have a line that is a positive slope. It's going up from left to right very gradually. If you make a slope of 0, in other words, you change k's value to 0, then it becomes a flat line at the origin, right, which is basically telling you it's the x-axis, right? So any equation y equals 0x is basically just the x-axis, because no matter what value you have for x, y is always 0. Okay, so that's kind of how it works when you're playing around with the slider and stuff like that, right? So you can kind of go through and kind of mess with it, right? So if you want a slider and you want to mess with it, that's kind of one way to do it. Now, another thing to notice is that all the things we talked about so far are positive slopes, but you could also have negative slopes. So if I were to take that multiplier, right, that constant proportionality, and make it a negative multiplier, all of a sudden now the slope is not going up from left to right, it's going down from left to right. So a zero slope is a flat line, and then a negative slope, a negative multiplier, is going to be a line that goes down from left to right. So this one of negative 0.5 basically means negative 1/2, which means that you're changing the y by negative 1 every time you change the x by positive 2. So as you move over 2 on the x-axis, you're dropping down 1 on the y-axis. And it still goes through the origin, right, because it's still a proportional equation, y equals kx. So any proportional equation is just a multiplication relationship between x and y. The multiplier is the slope. If the slope is negative, the line is going down from left to right. If the slope is going to be 0, then the line is flat, right? And if the slope is positive, the line is going up from left to right. A slope that is greater than 1 is basically bigger than a 45-degree angle, so it's very steep, right? And it gets increasingly steep very quickly as you increase that multiplier, right? And that's kind of how proportional lines look when you graph them. And so that's kind of how you can see the connection between the two. If you were to take a, let's kind of leave it at 1 here, okay? If you were to take the time to write in another equation here, let's say a non-proportional linear function, that would be in the form y equals mx plus b, all right? Now, it's basically exactly the same as y equals kx, all right? It's just that there's a plus at the end of it. So you'll notice that in this situation, if the m is 1, same as the k is 1, right? The m and the k are both the rates, right? The slope. How outputs are changing every time input is changed by 1. That's what those multipliers are. So if you are talking about mx plus b and you had an m of 1, notice that the blue line, the y equals mx plus b line, and the red line, the y equals kx line, both have a slope of 1, so they're parallel lines. Anything that has the same slope is going to be parallel. And so when we're looking at this one, y equals mx plus b, the main difference is that plus b. And the b represents where the line crosses the y-axis. So in a non-proportional linear function like the one in blue, it just means that the line doesn't cross at 0, 0. It crosses above or below 0 on the y-axis. So we call the place where the line crosses the y-axis the y-intercept. So in this case, you guys can see that when the b value is 0, right, this line crosses the y-axis at the order pair 0, 1. When x is 0, y isn't 0. When x is 0, y is 1. And that's what that effect of the plus 1 is, right? If you were to change what you're adding, and you were to, let's say, make that plus 2, all you're doing is you're shifting the line up, okay? The slope of the line stayed the same. The multiplier stayed the same. So it's parallel to the previous line, y equals kx, where k is 1, but it's just above it. If you were to subtract instead of add, so you make that b value a negative 2, you notice it just moves it down. So it's just basically saying that you're going to shift that line down from the origin. So it crosses below the origin. Now you can see it crosses the y-axis at negative 2. That's the b value, right? Well, this equation would be y equals 1x minus 2. So when you're working with a proportional equation, right, it's literally just y equals kx. Goes through the origin every single time and then has a constant rate. If you're working with a non-proportional linear function, it's just like that, right? It has a constant rate, has a constant slope, but the plus or minus value at the end of the equation basically tells you whether you shifted the line up or down. Both the red and blue line are lines. They're both predictable and have a constant rate. You can find that rate, that multiplier, by doing the change in y over change in x in both of those lines, right? So if you took any 2 points on the red line and you subtracted the y's and then divided that by the difference in the x's from those 2 points, you would get the same ratio. In this case, that ratio would be 1, right? And if you did that on the blue line, you'd get the same thing, right? Any 2 points on that line, the difference in the y's divided by the difference in the x's would be the same as the multiplier, 1 in this case. Remember, the multiplier works the same way on the blue line. So if you increase the slope, you're going to get steeper and steeper and steeper, right? So a slope of 3, as you can see, is much steeper than a slope of 1. On the blue line right now, a slope of 3 means to the right 1 and up 3, right? Slope of 3 means change in y of 3 every time the x changes by 1. So if you were to make the slope negative, it's just going to go in the opposite direction, right? So instead of going up from left to right, it's going to go down from left to right. If you had a slope of negative 2, for example, what does that mean? It means as you increase the x by 1, you're decreasing the y by 2. And if you have a zero slope, just like with a proportional situation, a zero slope is a flat line, right? Horizontal line. So the difference is that in this situation, right, it has a minus 2 value for the b, so it would be 0x minus 2. So actually what it's saying is it's a horizontal line, not at the x-axis, but 2 below the x-axis. Okay. Now, these are all linear functions that we've been playing with so far. So I can leave this as a value of 1 for x, and you can see the parallel nature there. And then we can talk about some other stuff. Okay? So the red line is a proportional linear function. The blue line is a non-proportional linear function. But then you also can have functions that are not linear. Okay? Now, one of the ones that we're going to see most likely in our investigations is x squared functions. So let me kind of show you how they play out. I'm going to erase the 2 linear functions for a moment, just so we can start to play with the idea of what happens with x squared. So if you have y equals x squared, you can always add the exponent by doing the keyboard, if I can find it. Where's the keyboard button here? I don't know where the keyboard is. Let's see if I can find it. Let me close this out. There it is. All right, so there's the keyboard. So there's your x squared. All right, so this green graph that you're looking at here is the graph of y equals x squared. And what you'll notice about y equals x squared is it's a shape that's special. It's like a U shape. Okay, it's called a parabola. If it has a positive x squared, that means as x increases, y also increases. And same thing when x decreases, y increases. Because remember, a negative times a negative is a positive, just like a positive times a positive is positive. So if x was negative 1, it's going to be symmetrical, right? And it's going to be a positive value of y, just like x is being 1. right? So -1 squared is going to be +1, just like 1 squared is +1. So you'll see that this is the graph of y equals x squared. Now, just to show you how we can adjust that graph, right? If you were to add a plus to it, right, you're going to do just like with linear function. You're going to be shifting the line up. So if I say +2, you'll notice that I'm shifting the base of that parabola up to 2 units. Basically, the lowest point in that parabola got shifted up, all right, to where we have 0, 2 is one of the points that's being on that parabola, all right? And x is 0, y is 2. If you were to shift it up even more, so it's going to go up higher, right? Now it's at 4, right? You're shifting it up. If you were to change that plus or minus to a minus, you'd be shifting it down. So you're not changing the parabola, right? You're just moving the parabola up or moving the parabola down. An x squared parabola is always the same basic shape, same steepness and everything. It's just that you're shifting it up or shifting it down when you add the pluses or minuses. So if you have y equals x squared minus 2 like you see here, it's just the x squared parabola shifted down 2 units. So that's kind of the effect of adding a plus or a minus. In terms of the actual function itself, right? If you have a situation where as x is increasing, y is increasing, and it's an x squared function, or you think it's an x squared function, all right? That means that it has to be a positive x squared. Because a positive x squared means that when x is positive, y is going to be positive. Upwards facing you or smiley face. If you want to have that being a downward facing you or sad face, right? Then you have to realize that the only way that would work is if you had a negative multiplier in front of it. So if you put a negative in front of the x squared, you'll notice that now the graph of negative x squared shows us to be a downward facing parabola. Still crosses at 0, 0, because when x is 0, y is 0. But it's not proportional because it's not a line. But you do notice that it is going to start 0, 0, and then be a downward facing parabola with the steepness of an x squared. If you want to widen the parabola so it's slower in terms of its acceleration downward or upward, all you have to do is change the multiplier, the coefficient of x squared, to be between 0 and 1. In other words, make it smaller. Instead of 1x squared or -1x squared, you're going to make it a value between 0 and 1. Okay, so watch. If I put 0.5x squared, notice it widened the parabola. If I put 0.25, notice it widened the parabola even more. Now, eventually, that parabola is going to still get very steep very quickly, right? But all you do with that initial change of changing the coefficient of the x squared is if it's a value that's small, it's going to slow that initial growth. So it's not going to accelerate quite as fast. That's why it widens it, whether it's accelerating up or down. If you were to, let's say, make that multiplier a larger value, like, for example, 2, what's going to happen is you're going to squeeze that parabola. It's going to get narrower because it's going to be accelerating at a faster rate than if it was a multiplier of 1. So watch. If I change that multiplier to -2x squared, it gets narrower. You see that? If I change it to -3, it gets even narrower. Change to -4, you can see it gets even narrower, right? Still a downward shaping U, still crossing at 0, 0 because we have no plus or minus in this particular function. But it is downward facing and narrower and increasing negatively at a faster rate. So if you want to narrow the parabola, you make the multiplier an absolute value that is larger than 1. If you want to widen the parabola, you make the multiplier with the coefficient of x squared an absolute value that is between 0 and 1, okay, less than 1. So that's kind of the idea. Remember, if you have a positive x squared, it's going to be facing up, just like we see here. If you want to make it a narrow one, I could do like 0.25. It's going to, or wider, I should say. And 0.25, it's going to widen out. It's going to slow it down. If I want to make it narrower, I'm going to speed it up by accelerating it. So I'm going to, let's say, make that multiplier 5. Make it very narrow, right? 10 would make it even more narrow. You can see that 100 would make it even more narrow, right? So you can mess with these functions to kind of see what they look like. So this is what an x squared looks like and how it performs. Y equals positive x squared is upward facing u. Y equals negative x squared would be a downward facing u. And then depending on what the coefficient or the multiplier is in front of that x squared, you're going to either have a wider or narrower version of that parabola. Okay, upward or downward, depending on the positive or negative. Anyways, hopefully that makes sense to you guys, and it helps you start to see what the functions might look like. All of these are functions, because for every single input, there is one expected output. And basically, every single one that I've shown you, y equals x squared or variants of that, y equals mx plus b, or y equals kx, they're all functions. Okay? All right, hopefully that helps you guys understand the basic idea of how they